finding the empirical formula of a compound from percent composition data. So the idea here is that you have some compound and you don't know what it is. So you do some analysis, you break it down into its different elements, and you weigh how much of each kind of element you have, and then you can come up using that data, using that percent composition data, you can come up with the empirical formula for that compound. The empirical formula is, again, it's the most simplified formula of the compound. It just tells you the ratio of moles for the compound. So here's the procedure. The first thing you do is you're given your data, your percent composition, and you assume that you have 100 grams of the material. So if these are the percentages, then for carbon you have 37.47 grams of carbon in that substance, in 100 grams of that substance. And for hydrogen you have 12.61 grams. And for oxygen you have 49.92 grams. The next step is to convert all of this into moles, and to convert grams to moles you divide by the molar mass. So dividing this by carbon's molar mass, 12.01, will get you you get 3.120. Okay, so that's moles now. For hydrogen, the molar mass is 1.01. So 12.61 divided by 1.01 gets you 12.485. And then for oxygen, you're dividing by 16. 49.92 divided by 16 gets you 3.12. Okay, now the next step, once you've converted these all to moles, is to look at the numbers that you have and see which one is the smallest. Now in this case, two of them, the smallest number is the same for both carbon and oxygen. So it doesn't matter which one you use. You take the smallest number, so 3.12, and you divide all of the numbers. You divide every single number by 3.12. Okay, 3.12. 3.12. Now for the top and bottom, it's pretty easy. You get 1. And for this one, plugging it into the calculator, 485 divided by 3.12, you get very close to 4. Okay, so I'm getting 4.00 here. All right, so because all of my numbers at this point are very close to integers, I am done. And I can say that this particular compound it consists of carbon, hydrogen, and oxygen, and there's 1 mole of carbon for every 1 mole of oxygen, and then there's 4 moles of hydrogen in the compound. Okay, so that's the empirical formula. Now the next one's going to be a little bit more complicated. We'll see how that turns out. So we do the same thing. You start by converting your percentages into grams. So 33.33 grams of carbon and 7.47 grams of hydrogen and 59.20 grams of oxygen. I like to do it exactly as you're seeing me write this out here. It keeps everything nice and neat, very organized, Harder to make a mistake that way. All right, so dividing this by the molar masses, whoops, 12.01 gives me 33.33 divided by 12.01 equals 2.775. Notice I'm not rounding too much when I do this also. I want to keep some digits because if I start rounding too soon, I can end up getting a wrong answer at the end. Alright, so 7.47 divided by 1.01, I get 7.396. And finally, divided by 16, 59.20 divided by 16 is 3.7 exactly. Okay, so I've converted these to moles. So mass to moles. Then I'm going to divide everything by the smallest number, which in this case is the carbon, 2.775. So dividing by everything by 2.775. That one's easy. That gets me 1. Divide by 2.775 here. And let's see what we... 2.66. Okay, so that's not a nice integer, which is why this problem's a little bit more interesting. 2.775, again, 3.7 divided by 2.775 equals 1.33. Okay, now, here in this first problem we ended up with nice integers, and so we were done. In this case we didn't end up with nice integers. We ended up with 1, 2.66 and 1.33. They're not nice integers, but they are nice fractions. Okay, so 2.66 is very close to 2 2/3, and 1.33 is very close to 1 1/3. So to make them nice integers, we have to multiply them all by some small number in order to get them all to be nice integers. And this 2 2/3 and this is 1 1/3. If I multiply all of these numbers by 3, I will end up getting nice integers, which is what I must have for my empirical formula. So 3 there, 2.66. 2.66 times 3 gets you 8, and 1.33 times 3 gets you 4. Okay, so now I have my nice integers, and I can put those as my subscripts into the empirical formula. So the final answer here would be C3H8O4. Okay, so that's finding the empirical formula from percent composition data. Thanks for watching.